So a dependent variable is the outcome. An independent variable is the input, the one that's being changed to see what happens. So what would be a letter? Which one of our letters, X or Y, would be the input? Which is the one that we're always changing? The X or the Y? When we do our table of values, which is the one we're changing? Because inputs are the ones that are changed. Okay, let's add that in. Ones that are changed. So which letter do we change to see what happens? The X or the Y? Think about the input-output table. Which letter are we always changing to see what happens? The X, yeah. So the independent variable, the one that's changed, is the X variable, which means that the outcome, the dependent variable, is which letter? Who's left? If the input is the X, then the outcome must be which one? The Y. Okay. So when you're thinking of the situations, you're looking at which one are we going to be changing and which one is what happens because of the change. Okay. Now, directional relationship, they put that here, directional relationship. They are asking whether it's positive, which is increasing, or negative, which is decreasing. Okay, that's what they mean by directional relationship. Is it an increasing relationship? Is it a decreasing relationship? Okay, and now we're going to go do our sentence. First, we have to think, it says, does the amount of fertilizer affect the height of the plant? So which one of those would we be changing? Which one are we looking to see happens because of the change? So are we changing the height to see how it affects the fertilizer? Are we changing the fertilizer to see how it affects the height? What does it say is happening? Read what the question says. Which one is the one that we'd be making changes to? Fertilizer or plant height? Which one do we think is doing the change and which one got changed? Okay, so which one is doing the change, the fertilizer or the height? Think about which one of those you would control. That's going to be the one that's doing the change. That's going to be the independent variable. Which one of those two things, fertilizer or plant height, do we have control over changing as humans, that we have control over? The fertilizer. So the independent variable, the one we have control over, the one we can change, is the fertilizer. Okay. Let's put amount of, so we keep the words the same. Okay. And the dependent variable is what's left. What's left? The plant height. Okay. So we defined who is dependent and who is independent. Now we have to think about, what do we think is going to happen? Do we think that as we add more fertilizer, the plant's going to stay small? Or do we think that as we add more fertilizer, the plant's going to grow big? Do we think that adding more fertilizer, the plant will stay small? Or do we think that adding more fertilizer, it'll make the plant grow big? Well, you guys know what fertilizer is, right? Okay, that's plant food, right? So we think that the plant is going to grow bigger the more fertilizer we add, but we have to do it in independent affecting dependent variable. So what is our prediction? So if we rewrite it from the independent point of view, we would talk about the fertilizer first, because independent is fertilizer, right? So as the amount of fertilizer is, what is the math word for get more? Starts with the letter I. What do we call it when we're getting bigger? Starting with the letter I. Look up at how I explained the directions. Increases as the amount of fertilizer increases, the height of the plant will, what are we thinking will happen? What do we think will happen? The plant will use the same word. Don't say grow bigger. Use the I word. As the amount of fertilizer increases, the height of the plant will increase. This makes, okay, direction. What direction is this relationship going then? Look at how we define the directional relationship words. We're saying that this is increasing. So what kind of relationship is that? No. What is increasing linked to? Look at the two words that we use for that directional relationship. Which one's linked to increasing? Starts with a P. Remember, we defined them up here. If we have increasing, what kind of relationship is that? Positive. This is a positive relationship. Okay, this is the exact kind of statements we're going to do for all the rest of these, but we're going to be changing up the words in them. But the general format's the same. So I'm going to copy and paste the format. So then I just have to be fixing up, changing increasing, decreasing, changing who's the independent, dependent. But the format's the same. We always start with defining the independent and dependent variables. Now this says how deep the seed is planted in each pot affect the plant height. So which one of those two are we controlling? So we have to call it the independent variable. Which one of the two situations And this is what I mean by situations. This is one situation, and this is the second one. So those are our two situations. Which one of those is the one we control? So I'm going to go highlight those. So one of these is always going to be independent, and one is always going to be dependent. The one we can control is independent. So what are we going to say for B is the independent variable? Which one of the two highlighted things do we as humans have control over? The green statement or the pink statement? And whichever one it is, tell me what we're picking. Which one of those two, the green statement or the pink statement, as humans, do we have control over? Okay, so actually tell me which one of those two statements then would I be typing out as the independent, the one I have control over? The independent variable is what situation? Just like we said up here, the independent variable is the amount of fertilizer. So I need to fill in this, instead of saying amount of fertilizer, I'm going to replace it with what words? Type out the words I should be typing in. Tell me what words I should be typing in. I don't believe the independent variable is the seed, because that's not the green phrase. What you need to be typing out right now is the green phrase, because that's the independent variable. So tell me, what is it that we're claiming is the independent variable for this situation? How deep the seed is planted. Thank you. How deep the seed is planted in each pot is the independent variable. The dependent variable is still the plant height, the thing we can't control. Now we're going to just copy and paste this phrase, how deep the seed is planted in each pot. I don't want to have to keep typing that. It's going to down here. So as how deep the plant is planted in each pot increases. So the deeper you plant it, okay, increases. The deeper you plant it, so the number of inches down it goes is increasing. It's getting farther and farther down. Is that going to make the plant grow higher, or is that going to keep the plant small? What do we think? If we plant the plant 4 inches deep versus 2 inches deep, do we think that that deeper is going to make it grow taller, or do we think that deeper is going to make it stay small? What do you think? This is completely a hypothesis. We haven't figured out if it's true or false. We're deciding whether which is true or false for us. So do we think that planting it deeper is going to make it taller or not taller? Do we think that planting it deeper will make it grow taller? Or do we think planting it deeper will keep it small? What do we think? We think it'll keep it small. So are we going to say the height of the plant will increase then? Does that mean stay small? No. So we have to change up these first two letters and say will decrease, right? So what kind of relationship is that then? Are we going to say positive relationship still? No, it's a negative relationship. Because as one goes up, the other comes down. Okay, next one. So let's go do this. First phrase, situation 1. Second phrase, situation 2. Which one of those is our independent variable? Which one do we have control over as human beings? Remember, independent are things we have control over, things we can change. So which one of those two things, what phrase are we going to say is the independent variable this time? Okay. So we think the number of seeds in each pot we have control over. Yes. Okay, so changing it to red, the number of seeds in each pot is the independent variable. The dependent variable is the height. Copy and paste the phrase, the number of seeds in each pot, because I don't want to type it again. This is where Cammie's beautiful, because I don't have to write it again. So as the number of seeds in the pot increases, so we have a pot, right? We put seeds in. Do we think the number of seeds, as more get in the pot, will the plant get bigger or stay small? If we put more of them in one pot, will the plant grow bigger or stay small? So if I have 6 seeds in the same pot, I think all 6 will grow really tall. Or do I think that when I have 6 seeds in the pot, they're going to kind of stay small, as opposed to 2 seeds in the pot? What do we think? If we cram a whole bunch of seeds in the same pot, is that going to make the plants grow bigger? If we put a whole bunch of seeds in the same pot, do I think that those plants will thrive and grow bigger or stay small? If there's a whole bunch of them as opposed to only a few. Oh, yeah, because if there's so many packed together, they're competing for everything, right? So they're going to stay small. So as the number of seeds in the pot increases, the plant will increase or decrease. Decrease. Yeah. Okay, so the height of the plant's going to decrease. Okay, so what kind of relationship are we going to say? Are we going to say positive? Negative, because as one goes up, the other comes down. Okay, first concept, size of the pot. Second concept, height of the plant. So who is going to be independent? Which one? Which one do we as humans have control over? Remember, that's the ultimate thing. If we have control over it, it's the independent one. If we can change it because we have control over it, then it is the independent one. So what are we going to say is the independent one? What are we going to say is the independent one? I have a couple private messages that need to be responded to. What are we going to say is the independent one in D? Which do we have control over? That's independent. The size of the pot, exactly. Okay, so the size of the pot is independent. The height of the plant is dependent. Okay, copying the size of the pot because I don't want to retype it. Okay, as the pot size gets bigger, do we think the plant's going to stay small or get bigger? So think of little pot, maybe the size of the cup, versus a bigger pot, that's like this big around. So do we think that as the size of the pot gets bigger, the plant will grow bigger? Or do we think it'll stay small? Think about it. Small little space as opposed to bigger space. Is that going to make our plant bigger if it gets more space or stay the same if it gets more space? It's almost the reverse of the last one. Because if we have a whole bunch of seeds, they're taking up space, right? So if you have more room, will the plant grow bigger or will the plant stay the same? It's not a but, it's a if the pot is bigger, will it grow bigger or stay the same? Bigger. So will the height of the plant will increase? Okay, so that's good. And that is a positive. So we're done. We didn't have to change too much on that one. Okay. First thing. Second thing. Which one do we have control over? Who's our independent? The number of hours of sunlight is something we have control over. Yes, the number of hours of sunlight per day. Now, I'm going to add in this little parentheses on the plant. Because obviously, we do not have control of the number of sunlight hours in a day, right? They're talking about sunlight hours per day on the plant. But they didn't say on the plant. They figured you would understand. So if we increase the amount of sun the plant has, will that make the plant grow bigger or stay the same? So I'm going to copy this piece. If we increase the number of hours the plant has sun, will that make the plant grow bigger or stay the same? It'll grow bigger. So the plant increases, so it's positive. Another one that's done. Okay. So the big thing is looking at there's two things that are happening. One of them we as humans can control, the other we can't. It's always going to be something that's out of our control. It's the thing that it's what's happening. So we don't have control over it. Okay. So now we're going to actually check if the amount of fertilizer affects the plant's height. So we're going to test one of these hypotheses. Okay. We're going to test what we believed was going to happen, that as we increase the fertilizer, the plant's going to grow bigger. That's what we said, right? So now we're going to go test it out, and we're going to do the graph for it. So the students went ahead and they measured the plant over time, and they changed up how much fertilizer the plant was getting. Okay, so this says they got 5 milliliters of fertilizer for 3 weeks. They got 10 milliliters of fertilizer for 3 weeks. Got it? These are the amount of fertilizer. So is that going to be our X or is that going to be our Y? Because remember, we said at the very beginning that independent is the X and the dependent is the Y. So what are we going to say for amount of fertilizer? Was that our dependent or independent? Was that our X or was that our Y? It was our X. Okay, so this is the X, meaning this is the Y. So when we go graph, we have our coordinate pairs, right? And I'm going to write those coordinate pairs before I go graphing them. I'm going to turn this table into my coordinates. Okay, the first one is 5, 14. What's the next one going to be? So we're just making our list of coordinates to put on the graph. That's what we're doing. Oh, I don't want to do that. We're just making the list of coordinates that we're going to put on our graph. So what's our next one? 10, 17. Okay, keep going. After that, what are we going to get? So 5, 14, 10, 17, keep going. We need all these coordinates. Keep going. We need all of the coordinates. 15, 21. Keep going. 20, 31. 25, 33. And 30, 40. So all we did was convert the table into coordinates so we could graph them. Now it says to clearly label your axes, mark your equal intervals, Title your graph appropriately, such as the experiment's question. So we have our coordinates that we're going to be graphing. This is what they mean. We have to use this title as the title for our graph. Okay. So the title of this graph is not that, this. Does the amount of fertilizer affect change the plant height? So we needed a title, and it's the question. That's the title. That's the title of our graph. Okay. We know that this top line is the Y, right? What does the Y stand for, though? What are we measuring the Y? What is the Y's measurement? I'll put this up, out of the way. What were we measuring the Y's by? What were we measuring the Y's by? What does the number 14 stand for? What were we measuring? What words are next to the Y in our table? That's what we're measuring. So can somebody do it? What are we measuring by? What does the Y stand for? Be specific. Because we're making a graph that other people would look at, and you have to put the details on the graph. So it's not just the height. The height of what? How are we measuring it? What is the Y standing for? Take the words off the table exactly as they are. What is the Y standing for? Use the exact words from the table. Yes. Height of plant in centimeters. Okay, so what are we going to say the X stands for? Because we know X goes sideways, right? What are we going to put down here for what the X stands for then? Exactly the words from the table, just like we did. So what are we going to put? So you're not reinventing titles to stuff. You're using what's already there, word for word. So what are we going to say down here at the bottom? Word for word from the table. For the X. Exactly what's in the table for the X. What does it say? Amount of fertilizer. Keep misspelling it. Over 3 weeks. Is it 3 weeks? No, 3-week period. Now, what is this lowercase m capital L? What does that stand for? Because I know CM. What's CM stand for? What's CM stand for? We have these measurements in parentheses. We need to know what they stand for. So what does the CM stand for? Centimeters. What's the little m capital L stand for? Milliliters. Okay. You know, Gallon is about a liter. They're talking about milliliters, right? Little tiny bits of fertilizer, not huge amounts. Okay, now we have to do our scale. How many lines do we have to work with up and down? How many lines do we have to work with side to side? This is what we worked on yesterday, and some people had a really hard time with it, even though we've done it before. So how many lines do we have up and down? How many lines do we have side to side? Are they different? Okay, so how many lines do we have then? Now I just decided to do something tricky and see if this works. I'm gonna take this and do it this way. So it goes down the side. See if it looks cool. It's not too bad. I'm gonna do that. Because that's where it would be. In a real graph, that's where this information would be along the side. So I put it along the side. 15 lines, okay. So for the X, what's our maximum X? 30. So if we have 15 lines, but we've got to go 30, how much is each line worth? 2. So we're going to type out here that we have a 30, right? And each line is worth 2. We know that. So we're going to put our lines in, tick marking for us. Now remember, our lines were different measurements yesterday, and that kind of was really, really messing with us. They're going to be different measurements today as well, but we're going to go ahead and highlight what they are this time. And the way to do that, the trick is, let me get my last couple lines in 1 second. To tell them what the very first line is worth. That line is worth 2. That means all the lines are going to be worth 2. Okay, now we have to go up and down. We have to go up and down. What's our highest Y? 40. We have to divide 15 into 40, round that number up, and multiply by the 15 to figure out how high this graph is going. So each line's worth the same amount. So how many 15s are in 40? If I divide 15 into 40, what do I get? If I divide 15 into 40, what do I get? Use your calculators, guys. Come on. What is 40 divided by 15? What is 40 divided by 15? 2.6. Round it up, multiply by 15, because that's how many lines we have. What would our highest line be? Round it up and then multiply by 15 to get our highest number. We know our lowest number is going to be 3. But our highest number is going to be what? 45. Okay. And I should have shown you the trick about writing the first spot so we could remember instead of having to write this one's going 7 and this one's going 4. You just do the first one so we know it's going by 3s for this direction and 2s for this direction. So if I have to do 5 to the side and 14 up, where is my dot going to end up being? Bless you. 5 to the side would be between the second and third dot. But we have to go 14 up. And we're dividing by 3. How many lines up would that be? What's 14 divided by 3? Use your calculator. Do 14 divided by 3. What do we get? $4.6. So I'm going to be between the 4th and 5th line, right? So 1, 2, 3, 4, almost halfway, a little bit higher than halfway, right? And that was the coordinate 514. So I'm going to go grab it from my list that I made already and put it next to its dot. But that's too big. Okay, there's our first one. We have to go do the second one and third one and fourth one. So we've got to get going. Okay, 10, 17. About where is that going to be? How much over for 10? How many lines over would 10 be? 5 lines. Okay, so let's go get to the 5th line. 1, 2, 3, 4, 5. And then we have 17. That's dividing by 3. Because we decided, see, we told ourselves it's 3. So how high up is that going to be? $17 divided by 3. How high up is that going to go? 5.6. 1, 2, 3, 4, 5, and almost to the 6th one. And then we go copy the coordinate we already have made at the top of here. What would the next one be? If we're 15, 21, where's that going to be? How much over? How much up? How much over for 15? How much over for 15? What are our bottom lines going by, guys? What are we dividing by? $15 divided by 2. We're going over, and that's a 2. We see the 2 on the bottom for that reason. So how many lines over? Between the 7th and 8th, right? Now we have to do the other number. It was 15 comma what? $15 comma what? 21. So I don't think 21 divided by 3 is 8. I'm pretty sure. I can use a calculator and confirm that. Oh, so we have to go over between the 7th and 8th one. So 1, 2, 3, 4, 5, 6, 7, halfway, there's 15. And up 7. 1, 2, 3, 4, 5, 6, 7. We have done graphing a lot that this is taking so much time. It's crazy. Go on to the next one. How far over? How far up? Remember what the measurements are, because that's why we put the lowest number on the graph to remind us. Okay, so 20 is over 10, thank you. And then up what? 10.3, so a little more than 10. Not quite halfway. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and some more. Do I care that it's perfect? No. Get over it. You're not making a straight line. You're just plotting the points. It should be directly on the line though. Go get its coordinate. Get to the next one. Let's go. How much over? How much up? Over 12 and a half. Thank you. 15, 14, 13, 12 and a half. How much up? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops. Right there. Okay, put its coordinate on it. How about the next one? How much over? How much up? How much over? How much up? For our last one. Over 15, which means all the way to the edge, which is 30 times divided by 2 made 15. Okay. How much up? A little more than 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and just a little bit more. Do we care if it's perfect? No, we don't, because it's a scatter plot. We're just recording the information onto a graph so we can visually see it. Okay, now it says, we don't have to do this one. Woohoo! Examine the scatter plot and answer the following questions. For our data, what is the relationship? Describe the relationship. So, first thing we need to say is, what is going on? Who is controlling who? Okay, so we could use either one of these starters, except notice the bottom one is for if there is no relationship. So do we have a relationship? Is our fertilizer affecting how high the plant goes? Is the amount of fertilizer changing how high the plant goes? Like we thought, remember up in the very beginning, we said as the amount of fertilizer increases, the height of the plant increases. Do we still see that's happening? Now that we can visually see it, have we proven visually that as the amount of fertilizer increases, the height of the plant increases? Is that statement still true? Yes. So we have to type it up here because our starters are in the way. As, now what were we saying was getting larger? What was the first thing that was getting larger? Plant or fertilizer? Which one do we always talk about? The one we have control over first. So as what gets larger? Which one do we have control over? Okay, as the amount of fertilizer, because we have to use the words they gave us. Gets larger. What happens? Then what happens? In our situation, what was happening? Fertilizer was controlling what? What about the plant increases? Okay. So as the amount of fertilizer gets larger, then the height of the plant gets larger. Done. Now we have to tell whether it's a positive direction, negative direction, no direction. Okay. A positive direction would be low left, high right. A negative direction, high left, low right. And none is when they're just all over the page. So for our situation, are we a positive association, a negative association, or no association because our dots were just everywhere? So remember, positive is low left, high right. Negative, high left, low right. And then nothing is, they're just all over the page. So what are we going to say? Are we saying that we have a positive relationship or a negative relationship or no relationship? Okay, so we have to use a sentence. Decide if there's a positive association, negative association, or no association. So what are we saying? There is what kind? Positive, negative, or none? Positive association. How to spell? Connection is what that means. Between the amount of fertilizer, we always have to keep cutting back to explaining for them, and the height the plant grows, or the height of the plant. We could do that. Leave it there, height of the plant. So we keep the words all the same. Okay. Now we have to explain, are we linear or non-linear? So does it look like within reason that it's going at a straight line, or does it look like it's got a curve? So let's go back and look at our graph. In general idea, does it look like we're going in a straight line, or does it look like we're going in a curve? Because straight line is called linear, not straight line is called non-linear. Okay, so straight line, linear. So we would say the association is a linear form for the amount of fertilizer affecting the height of the plant. So we just keep going back to the same words of how they described it in the very beginning, okay? Now, outlier. Outliers like what happened yesterday. Outliers what happened yesterday where we had that one car that was 15,000 miles and $28,000, which is just too cheap, right? That was an outlier. He didn't fit our pattern. He didn't fit our pattern. Okay. So when they don't fit the pattern, they're called outlier. So let's go look. Do we have any spot that's totally somewhere else off the line? Or mostly are they all running in the same line? Do we have one that's way out there that's not fitting with the kind of general trend? Do we have any that are off, way off somewhere? If we do, where is it? What's the location? Okay. So an outlier would be on our graph, but let me show an example. If I was going to have an outlier for this situation, let's say they told me that at 10, my plant only grew 9. That would be an outlier because he's down here when we expect him to be up there. Okay. So it's not that it's a little bit, we're talking it did not fit the pattern at all. We expected growth and all of a sudden it gets smaller. We expected a little bit of growth and it's way up here. Okay, so outliers are entirely off the pattern. Okay, and in general, ours are kind of flowing along the same pattern within reason, right? So we do not have any outliers in our situation. So, oops, the scatter plot of amount of fertilizer affecting the height of the plant has no outlier because there's no one point or more than one point that are super off track. They're close. I mean, there's going to be a little bit of wiggle, but we're talking significantly high or significantly low. Okay. Were we accurate with our original hypothesis, which was the first thing we said way up here? Did what we say here, the amount of fertilizer, as the amount of fertilizer increases, the height of the plant increases, was our hypothesis correct? Was our original statement correct? Yes, so I'm going to copy our original statement. And I'm going to go down here and use it because I don't want to reinvent. Okay, we do not need the comment about independent and dependent variable. Okay, as the amount of fertilizer increases, the height of the plant increases. And then we're going to say why. So that was our hypothesis. Okay. We see this makes a positive association because all of the plants got taller as the amount of fertilizer, keep spelling it, increased, right? So we just took the same thing and we just said a little bit more to it. Okay. Going back to the picture for a second. Okay, so this was our picture, right? did the amount of fertilizer make the height change proportionally? So as we went up in fertilizer, the height of the plant increased by the same amount every time? Or did we see a spot where it started to level off, that we were getting almost too much fertilizer? Because if you look, when it was only 5, it was 14. 10 was 17, 3 between, right? Then 15 goes up to 21, 4. 21 goes up to 31, 10. But then it drops back down to 33. So I think our ideal spot looks like that 20 milliliters. Because once we go above that, it's not as dramatic a change. So sometimes that's what scatter plots will do also. Okay, sometimes scatter plots will let us see a trend and notice, oh, well, this is the level we want to stop at, because if we start going past that level, it could be bad. Okay, we are going to draw our line of best fit in now. Remember, the line of best fit does not have to touch or include existing spots. It's the general line that we think is going to happen, and we need about the same number of spots on either side. Okay, so we're going to go back to our graph. We're going to go back to our graph. We're going to draw in our line. Okay, so we need our line to go through. Does it have to include the spots? No, remember we talked about that. Could I make my line go here? Do I have about the same number above and below my line? Do I have about the same number above and below my line? Look at our line. Do I have about the same number of dots above my line and below my line? I'm going to put my line back in. This was my line. Are there about the same number above and below? How many dots are above? How many dots are below? Do I have the same number of dots above and below? Okay, so remember, that was how line of best fit worked. Does it have to cross through points? No. It has to make sure it has about the same number above and below. Okay, so we went and did our graph, and it said, draw the line in that stands for the line of best fit. Remember, it doesn't need to go through the origin. It doesn't need to connect with the points. It just has to make sure it has about the same number above and below. And that's what we did. Using this line, predict the height of the plant at 12 milliliters. And we're going to do a sentence here. Let's go back. Okay. So I'm going to look at where 12 is and take it up to our line and estimate what it would be. So I'm going to make this dot a different color. I'm going to make him blue so he stands out. How many lines over would 12 be? How many lines over is 12? 6 of them. 1, 2, 3, 4, 5, 6. And then I'm going to go straight up to my graph. I'm going to put the dot on my graph, and I'm going to estimate what that is. Okay. I know it's 12 comma something, right? Because they told me. 12 comma, about how much do I think this is? If I take this back over here, about how much is that? How much is each line up worth? How much is each line worth? 3. So how many lines up did that 12 go? Count how high up that is. How high up did our blue dot land? Did it land exactly 7 or a little bit higher than 7? A little bit higher than 7. Okay, so 7.1 or 7.2, something a little higher than 7, right? Times 3. But it has to be a whole number. So about how high do we think that is? If 7 is 21, what do we think ours is? If 7 is 21, what do we think ours is as a whole number? Since it's a little bit higher than 21. What are we going to say? What's a little bit higher than 21 as a whole number? What's the next number above 21? Because that'd be a little higher than 21 as a whole number. So why are we having to waste our time? A little bit higher as a whole number, guys. So what does the 12 stand for? What did the X's stand for? What does the 12 stand for? 12 what? What does the X stand for? I have to change those numbers into an answer now. What's the 12 stand for? What's the 22 stand for? What are we measuring by? 12 milliliters and 22 centimeters. Thank you. So, sentence answer. We predict, because we don't know for sure, that a plant that gets 12 milliliters of fertilizer over a 3-week period will be about 22 centimeters tall. High. Same thing, right? Okay. What is the y-intercept for our situation? Y-intercept is where our line is crossing the y-axis. So what is the coordinate for our starting value is what they're asking. I'm gonna put him in green. What is the coordinate for our starting value? Remember, start is over here. We've done start before. What do we think that coordinate is? That start value. How tall would the plant be when we start? All our start values have a value for X of what? Same as it's always been. The start values X is 0. So 0, comma. How tall, how much fertilizer are we starting with? 12. Are we? 0 fertilizer. How tall are we saying our plant is to start? Sorry, 12 centimeters. So did we start with a seed? No. We started with a baby plant, not a seed, because we believe it starts here. So we must have had a plant to start. Gauge, enough. Okay. So our y-intercept is 0, 12. It tells us how much fertilizer that we have. How much fertilizer? If it's 0, 12, no fertilizer, and a plant that is how tall? 12 centimeters. So we didn't start with a seed. We started with a plant. We didn't start with a seed. We started with a plant. Okay. Turn in our notes, please. Make sure you hit turn in on the Cami. Make sure you hit turn in on the Google Classroom.